Okay, in this video, I'm going to continue estimating the quantity-dependent Kepler equation. This is the result we got from the last video. So like I mentioned, I got the real price of chicken as a statistically significant variable to explain the quantity demand of chicken on the left-hand side of the equation, and also my real per capita income has a positive impact on the demand of chicken. So I'm only going to include these two variables this time in running a new model, and I'm not going to include the rest of the three. Like I mentioned, the real price of turkey is statistically significant, but because of the sign, I got a negative sign that shows turkey and chicken are two complementary products. So it does not make economic sense. I'm not going to include this variable in my next estimation. Okay, so now let's run a new regression. So in this new regression, my left hand side is still the per capita consumption of chicken, which is my Q. On my right hand side, I'm going to include my real price of chicken as my first explanative variable, and I'm also going to include the real per capita income. So in order to include these variables, I have to copy and paste my real per capita income. I'm just going to move it to just very close to, the column next to real price of chicken, so I can easily include these two variables together when I'm running the regression. So let me just go click data analysis, pick regression, click OK, and my input Y range is going to be my per capita consumption of chicken, and my input X range, I'm going to include my real price of chicken and also my real per capita income. Okay. Oh, did I include too much? Let me just do it again. Okay. And I'm going to pick my output range. I'm going to request it to appear right below my first estimation, and I'm just going to click OK. Okay, so now let's take a look of what we got. So in terms of R square, it's high, is 97%, which is higher than 80%. So I'm confident my estimation is valid. But if you want to double check, you can still go to the F and significance of F. Those statistics are significant. But because it is above 80% of an R square, I'm not going to go check the F and significance of F because it's good enough. I'm confident my model is valid. So now let's take a look of our coefficient estimate for my T stat and my P stat, and I am going to highlight them. Okay, so if you look at my real price of chicken variable, it is negative. That's what we wanted to see because we wanted to depict a negative sloping demand curve. So in this case, we do find out the real price of chicken has a negative impact on the per capita consumption or demand of chicken. So that's why we can show a negative sloping demand curve. And in terms of the magnitude of this coefficient, we got a 15.82. So that means when the real price of chicken goes up by 1 unit, in my case is $1, the demand of chicken would drop by 15.82 pounds. Okay, so let's look at our real per capita income. it's a positive coefficient. That means when the real income goes up by $1, my income is in dollars. When real income goes up by $1, people would be willing to pay 0.3 cents to purchase a pound of chicken. So it's less than it's 0.3 cents. It's less than 1 cent. So income does have a positive impact on the per capita consumption of chicken, but the impact is very tiny. And let's check the t value and p value. Very big T, much bigger than 2, and very small p, a lot lower than 10%. So we are confident these two variables are statistically significantly impact the per capita consumption of my major commodity, and their signs make sense, make economic sense. So we are going to include these two variables in my finalized equation. So this is my finalized equation for my quantity dependent demand equation. Thank you.